A bridge under construction has a bridge ends here sign. The bridge is constructed over a river that is 70 feet below. A drunk driver speeding at 75 miles per hour misses the sign and goes off horizontally from the end of the bridge. What is the horizontal distance in feet from the point at which the car runs off the end of the bridge and at which the car hits the river? Okay, so the first thing we gotta do is we gotta convert this 75 miles per hour into units of feet per second. So in order to do that, we know that 5,280 feet are in 1 mile, and we can go ahead and cancel out the miles, and then we have feet over hours. And from there, we can do 1 hour equals 3,600 seconds, and we can go ahead and get the hours out, and now we have feet over seconds. Now when we plug that into a calculator, we get 110 feet per second. And from there, we can go ahead and try solving our problem. So the problem asks, what is the horizontal distance in feet from the point at which the car runs off? So looking at a diagram, we have the car going off a horizontal. And that car is going to be the time it takes to get from this point all the way to this point. And to solve that, we can go ahead and use this formula, which is the change in x equals velocity times time plus 1/2 at squared. Okay, the reason why we use this equation is because the car is going off a cliff, and because of that, it has a type of acceleration in the y direction. So we have to incorporate the a value. So now that we got that out of the way, we can go ahead and we can get the y components and solve for t. So we have delta x, which equals 0 minus 70 feet, because when it's at the bottom, it's going to be 0. So x final is going to be 0, and then x initial is going to be 70. So then we can set that equal to 0 because there was no velocity in the y direction. And we can go ahead and add that to 1/2 times negative 32.2 t squared. Now we can go ahead and carry this negative 70 over. So we have a final equation of 1/2 times negative 32.2 t squared plus 70. Now to solve for t, you can go ahead and use the quadratic formula. So because we don't have a b value, because we have, this would be a, and then b would be 0, and this would be c. We can go ahead and just not include it. So we have the square root of negative 4a, which is going to be 0.5 times negative 32.2. We can multiply that by c, which is going to be 70. We can divide all that by 2 times our a, which is going to be 0.5 times negative 32.2. And because this negative and this negative cancel out, we don't have to worry about that. But because this is a negative right here, time has to be a positive value. So there has to be a negative sign right here. And this would be equal to t. And when we plug that into a calculator, we get t equals 2.085 seconds. So now that we got the time, we can go ahead and use this formula, which is the change in x equals v2 plus v1, divide that by 2 times t. Now the reason why we use this formula is because velocity in the x direction isn't changing. We're just going to take the average of the two velocities. So because it's just going off of a horizontal, we can use this formula. So when we plug that in, we get 110 feet per second plus 110, and divide that by 2 times that by 2.085. Now the reason why Vt equals 110 is because we can use V2 equals V1 plus AT, and because our acceleration is 0, it was going to be equal to V1. So when we plug that into a calculator, we get 29.36. Now, going off of a calculator, we went ahead and converted our miles per hour into units of feet per second. And from there, we can solve for our final velocity using this formula. And because we have a zero acceleration, v2 is going to be equal to v1. And from there, we can go ahead and try solving for time. And to solve for time, we use this formula and we plugged in our y values. So we didn't have a velocity in the y direction, so that was just zero. Rearrange the formula and get it into this form. And then we can use the quadratic formula to solve for time. And that's what we did right here. Now that we have time, we can use this formula to solve for the change in x. So we have the v2 plus v1, divide that by 2, and then times our time, and then we get x equals 29.36, which is what we got.